Hello and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going through the practice paper 1 that they provided in the IB Math textbook. So let's jump right in. So as usual, I'm going to be doing every other question. I guess we'll do let's do the odd ones, and you're not allowed to use a calculator. So I don't have a calculator, and yeah, you shouldn't either. So let's jump right in. So the first question is 2 parts. First, we need to find the integral. Let me just write hence evaluate. So first, we need to find the indefinite integral of sine squared x dx. And then hence we need to evaluate the integral between 0 and pi of sine squared x dx. Okay, so how do we find this integral here? Well, we have to use double angle formula. So we know this indefinite integral is equal to 1/2. No, it's actually equal to 1 minus cosine squared x dx. But this is equal to, remember, if we get cosine 2x, this cosine 2x is always equal to 2 cosine squared x minus 1. So if we substitute that in here, we get that this is equal to the integral of 1/2 minus 1/2 the integral of cosine 2x. So 1/2 of this is cosine squared x minus 1/2. Yeah. So it's equal to this integral dx, and then we can simply integrate it from this point, because this integral will evaluate into 1/2 x minus 1/2 sine 2x plus c. Okay, so that's part number 1 done. Oh, sorry, it's 1/4 sine x, because there's a number. I mean, because we have to reverse differentiate the 2 inside here, so it becomes 1/2 x minus 1/4 x sine 2x plus c. And then for this part, pi and 0, well, we know that that is going to be equal to the between pi and 0 of 1/2 x minus 1/4 sine 2x. And so this is equal to pi over 2 minus 1/4 sine 2 pi is equal to 0. So that's 0. And then we have minus 0 minus 0. So this final answer is simply equal to pi over 2. So yeah, that was good. And on to the next one. And for the next question, we have a piece. A piece of wood is 290 centimeters long. It is going to be cut into 10 pieces. The length of each piece should be 2 centimeters longer than the piece cut off before it, and all the wood will be used up. So first, we need to find the length of the first piece of wood that is cut, and next the length of the last piece. So this is quite a simple arithmetic sequence question. We have the sum. We have the sum of the first 10 terms of the sequence is equal to 290, and we have the common difference is equal to 2. Okay. So we know that we can also rewrite the sum of n is equal to n over 2 times n over 2 times 2a1 plus d over 2. First term, average of first term times last, times n. And so now we can get the sum. So, plus nd, dn. Since, am I being silly? This should be times d times n minus 1. Over 2, And so we have, yep, 1/2 and 2a, yep. So this is equal to 10. So we have 290 is equal to 10 times 2a1. So actually this is just 5. We'll divide by 2 here. 5 times 2a1, or the first term, plus 2 times 9. So this is equal to 10a1 plus 5 times 18 is 90. So we have 10a to the 1 is equal to 200. So we have a1 is equal to 20. So the first term will be 20. So the length of the first piece of wood should be 20 centimeters. And the length of the last piece is 20 plus 9 times the common difference, which is equal to 38. So the last piece is 38 centimeters. Nice. Okay, that was pretty good. On to the next one, where we have let A, B, and C be three-dimensional vectors. State whether each expression below is a meaningful vector expression or meaningless, and justify your answer. So we have quite a few to go through. So first we have A times B times C. Next we have A scalar product, B scalar product C. Next we have A scalar product of B times C. Next we have A times the scalar product of B and C. Next we have B times C times A. Is that just B times C times A? And then the sixth one is B scalar product C times A. Okay. So first of all, A times B times C. Well, this looks meaningful. We just multiply vector product of 3 vectors. We'll get output of vectors, so it's meaningful. A scalar product, B scalar product, C makes no sense because you're getting the scalar product between a vector and a scalar. So there's meaningless. So we can't take the scalar product, so it's meaningless. A scalar product, B times C is meaningful. And this would be, I think it's the area of the parallel pipe, I think. This is the area of a parallel pipe, so this is meaningful. A times B dot C, meaningless, since you're getting the vector product between a vector and a scalar, so that's meaningless. B times C, and I guess this is times A. No, this is scalar multiplication. That's weird. So you're trying to do a vector multiplied to a vector using scalar multiplication, so that's meaningless. Remember, if there's no time symbol in between, this is scalar multiplication. And finally, B dot C times A is meaningful since this over here is a scalar and we're multiplying it to a vector, so it's meaningful. Nice. So next question, we have differentiate. the following function f of x is equal to x to the power 4 from first principles. Okay, is it just that? Okay, so that's cool. So we have the derivative is equal to the limit as h tends to 0 of f of x plus h minus f of x over f of h. Sorry, over h. So this is equal to the limit as h tends to 0 of x plus h to the 4 minus x to the 4 divided by h. And what you'll notice is we get this is equal to the limit as h tends to 0, and we can use binomial expansion of this to get x to the 4 plus 4x cubed plus 6x squared plus 4x plus 4x cubed h. Oops. 4x cubed h plus 6x squared h squared plus 4xh plus h to the 4 minus x to the 4 all over h. So these two terms cancel out, and now we can divide h from everything. So we have this is equal to the limit as h tends to 0 of 4x cubed plus 6x squared h squared plus 4xh. And so the neat thing here is we can now use limit rules. As h tends to 0, this will tend to 0, and this will tend to 0. So we're just left with 4x cubed. So that is the derivative from first principles. Very nice. Okay. And the next one we have a polynomial is defined by the p of x is equal to x to the 4 plus 10x cubed plus 35x squared plus 50x plus 24. So first, for p of x is equal to 0, write down the first sum of the roots. Sum of the roots, and next is product of the roots, and then we have another polynomial is defined by q of x is equal to p of x minus 1, and so for q of x is equal to 0, find, and then it's the sum of the roots and the product of the roots. Okay, so remember that we have the alternating form over here. So this number here, 24, will be equal to the product of the roots because if we remember, the last term should be equal to the product of the roots, and then this second term divided by the first term should be equal to the sum of the roots. So, yep. So the sum of the roots should be equal to 24. Just 24 divided by this the coefficient of this number, of course, because this number will affect the last number. So we have sum of the roots is equal to sum of the roots. Wait. No, sorry. This one is the sum and this one is the product. Sorry, I'm being silly. So sum of the roots is equal to the negative b over a, where b is the second coefficient, or it's equal to, probably better to say a to the n minus 1 over a to the n. So that's equal to negative 10. And the product of the roots is simply equal to 24. It's just 24 divided by the coefficient of the first term, but since this has no coefficient, it's fine. Because we want to remember that for alternating binomial expansion of the roots, it's equal to negative 1 to the power of, let me remember correctly, negative 1 to the power of, I think, n minus 1 times a to the n minus 1 over a to the n. Sorry, I mean negative 1 to the power of k over a to the k over a to the n, where k is the coefficient we're getting it from. Next, another polynomial is qx is equal to px minus 1. So the sum of the roots actually does not change. Wait, p of x minus 1. Oh, so we have to expand this actually. So it's harder than I thought. So we have to go x minus 1 to the 4 plus 10 times x minus 1 cubed plus 35 x minus 1 squared plus 50x plus 24. So if we expand this, we get x, I mean, is there a faster way? No, probably not. Plus minus 4x cubed plus 6x squared minus 4x plus 1. And then we have to add to this 10x cubed. So this would be 10x cubed minus 30x squared. But we really only care about this term and this term, so I'm going to skip the middle terms. So this is 10x cubed minus 10. We have to take the last one from this, so this is plus 35. And then we have 50x minus 1. So this is minus 50. And then plus 24. So we have, this is equal to negative 6. And this is equal to 1 minus 10, negative 11. This is 24, negative 26, negative 2. So we have the sum is equal to negative 6, negative 1 times negative 6 over 1. So the sum of the roots should simply be equal to 6. And the product of the roots should simply be equal to negative 2 over 1, negative 2. So yeah. Unless I did some math wrong. This is, we made an error in the math, perhaps. Oh, sorry, this should be 6. I added, okay, so this would be 6, so this answer should be negative 6. And the product, let's go over this again. Plus 1 minus 10 plus 35 minus 50 plus 24. Oh, what am I doing? This is 1 plus 10. This is only negative 9. So negative 9. 35 minus 9 is equal to 26. 26 minus 50 is equal to negative 24. 24 plus 24 is equal to 0. So the product of the roots is actually not 24, it's equal to 0. So yeah, that was that. Okay, time for some long questions. So for our long questions, the first one we have is, proof by induction. Prove by induction that, I'll write it out, and then by writing I times I factorial as I plus 1 minus 1 times I factorial, construct a direct proof for the result of A. So for our first proof by induction is we need to prove by induction that the sum, can't draw a sum today. Anyways, the sum from I is equal to 1 to n is equal of I times I factorial is equal to n plus 1 factorial minus 1 for I and n are all positive integers. So the sum, okay, so let's do our basic step where we prove this for n equals 1. So we have a sum from 1 to 1. So just we more or less just need to prove that 1 times 1 factorial is equal to 1 plus 1 factorial minus 1. So in this case, we have 1 is equal to 2 minus 1, which is of course true. So that is our basic step, and now we need to prove the inductive step. So assuming that this is true, what happens if we increase n by 1? So we need to prove that the sum from I equals 1 to n plus 1 of I times I factorial is equal to n plus 2 factorial minus 1. But we know that the sum from I to n plus 1 factorial, n plus 1 of this is equal to the sum of I is equal to 1 to n of I times I factorial, and then we add n plus 1. So this is n plus 1 times n plus 1 factorial. And we need to prove that all of that is equal to n plus 2 factorial minus 1. So on this side, we know that this, if we assume that our earlier proof is correct, this is equal to n plus 1 factorial minus 1. And so if we add n plus 1 times n plus 1 factorial, and then this is equal to n plus 2 factorial minus 1. If we cancel out the minus 1s, we can simplify this equation into n plus 2 times n plus 1 factorial, which is of course equal to n plus 2 factorial. Since if we multiply this in, this becomes n plus 2 factorial. So that is our proof by induction. Now, we need to find a direct proof by writing I times I as I plus 1 minus 1 times I, construct a direct proof. So if we just copy this over here, don't mind if I do, copy that over there, paste it over here. And we need to write I times I as I plus 1 minus 1 times I factorial. I don't know where we're going to go with this one. I equals 1 to n, so I plus 1 minus 1 times I factorial. And we need to prove this is equal to n plus 1 factorial minus 1. So I guess we can expand this into the sum from n to I equals 1 to n of I plus 1 factorial minus I factorial. Oh, okay, I can see where this is going, okay. And this is equal to n plus 1 factorial minus 1. And so what we actually end up over here with is we end up with 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial until n plus 1 factorial minus n factorial. And so since we can cancel out all of these terms, since they're repeating, what we do end up with finally is the first and last terms. Only the first and last terms remain. So this simplifies into n plus 1 factorial minus 1 factorial, which is 1. So this simplifies into n plus 1 factorial minus 1. So there is our direct proof. Okay. And then on to the final question. And the final question is a rumor about Katie is spreading in a college with a large number of students. Let x be the proportion of the college students who have heard the rumor, and let t be the time in hours after 9 a.m. This situation is modeled by the differential equation dx over dt is equal to kx times 1 minus x, where k is a constant. So first, use partial fractions to solve this differential equation, and hence show that x over 1 minus x is equal to ae to the kt, where a is a constant. Next, at 9 a.m., 1/3 of the students know about the rumor. Find A. Next, we have at 10 a.m., half of the students knew about the rumor. Find e to the k. And finally, hence, find the proportion of students who knew at 11 a.m. Okay, so let's get cracking. So we have differential equation dx over dt is equal to k of x times 1 minus x. Okay. K is a constant, and use partial fractions. So we have 1 over x times 1 minus x is dx is equal to k dt. So we can use partial fractions to break this down. We have 1 is equal to a times 1 minus x plus b times x. So we have 0 is equal to negative a plus b, and 1 is equal to a. So a is 1, so therefore b must be equal to 1. Is that correct? Yeah. So we have 1 over x plus 1 over 1 minus x. Dx is equal to k dt. So if we integrate both sides, we end up with ln x plus ln 1 minus x is equal to kx dt, I believe. So if we add these together, of course, this is going to be, sorry, is this plus or minus? So, adding logarithms together, yeah, so, this should be negative, sorry, because this is negative x. So when we differentiate, it swaps signs. So we get ln of x over 1 minus x is equal to kx. So kt, sorry, we integrated this side with respect to t. So this should be kt, this should be kt. So we have x over 1 minus x is O plus c is equal to e to the c times e to the kt. Oh, sorry, no, e to the c plus kt. Hey, yeah, e to the c plus kt. And remember, we can express e to the c as a constant, so we can rewrite this as ae to the kt. So that's done. So first, at 9 a.m., 1/3 of the students know about it. Find A. So T is time in hours after 9 a.m. So 1/3. So we know that 1/3 over 1 minus 1/3 is equal to a, since this will be 1. So we have 1/3 over 2/3, or 1/2 is equal to a. So a equals 1/2. Okay, so that's cool. Next, at 10 a.m., this should say 1/2. One half of the students? No. So we know that 1/2, more or less 1, is equal to 1/2 e to the kt. So we need to find the value of e to the k. And this was at 10 a.m. So this is 1 hour after, so it's simply e to the k. So we have 2 is equal to e to the k. So yeah, that's cool. And then finally, hence find the proportion of students who knew about the rumor. So we can rewrite this as x over 1 minus x is equal to 1/2 2 to the t, or in other words, 2 to the t minus 1. And if we substitute t in as 2, we get 2 to the 2 minus 1, which is 2 to the 2. So x over 1 minus x is equal to 2. So we have x is equal to 2 times 1 minus x. So we have 3x is equal to 2. So x is equal to 2/3, I think. So by that point, 2/3 of the student body should have known about the rumor. So yeah, that's correct. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.